This is my video on separable differential equations. So let's take an example. So consider this differential equation: dy over dx is equal to x squared over y squared. Why we call this separable is that you can see that you can actually separate the y and the x's very easily. So for example, if you cross multiply, then this on the left side you get y squared times dy, and then on the right side we have x squared times dx. So the y and the x can be separated very easily, so that's why we call them separable differential equations. So the first thing to do would be to now separate them into something on y and something on x on the two sides. And now what you do is you integrate both sides. So when you integrate y squared with respect to y, you get y cubed over 3. When you integrate x squared, you get x cubed over 3, and then you get a constant. Okay, and now if you want to solve for y, you first of all multiply by 3, you get y cubed equals x cubed plus 3c. But now 3c is a constant times 3, so we can actually call it by a single constant c. So you get y cubed equals x cubed plus c, and then if you want to solve for y, you take the cube root on both sides, you get cube root of x cubed plus c. Now they want you to also just not leave the answer like that, but they want you to find the value of c by giving an initial condition. So this type of problem is called initial value problem. So what you do is you put the initial condition, which is y0 equals 2. So you put x equals 0 and y equals 2. So that is to find c. Okay, so you get 2 for y, and x is 0, so you get 0 cube, x is 0, so 0 cube plus c, and the cube root is still there. So 2 is equal to cube root of c, so c would be equal to 2 to the cube, which is 8. So now we found c. What you do is you take the c and plug it back here, so this becomes 8. So now the final answer is y equals the cube root of x cubed plus 8. Alright, so that's the final answer. That's a specific solution, a particular solution for the initial value problem. So now let's take another example. Again, we have dy over dx equals 6x squared over 2y plus cosine y. So again, here also y and the x's can be separated very easily. So we can take the y onto this side and we can write it as 2y plus cosine y at times dy on the left hand side, and then we can cross multiply and get 6x squared dx on the right hand side. So if you integrate this, you get the integral of 2y is y squared plus the integral of cosine y sine y is equal to integral of x6 times x squared, integral is x cubed over 3 plus c. So if you write this, you get y squared plus sine y equals 6 over 3 is 2x cubed plus c. And so now y is actually not given as y equals something, but y is given implicitly, right, as an equation involving y and x, right? And you can always draw the curves for this, right, and get the answer. Alright, so so that's a very short video for separable equations. So what you do is, these are equations where the equations can be separable, so the variables can be separated, and what you do is you separate the variables and you integrate both sides, the y and the x. Thank you for watching.